Thanks everybody for attending today. So the title of this talk is Lessons from Driverless AI Going into Production, but it's almost going to be more about, as you're thinking about onboarding driverless AI, what are the different things to consider? And at the end of the talk, Venkatesh has put together a bunch of the different questions that people have asked us over the deployment of driverless AI into organizations over the last 8 months or so. So I'm going to go pretty quickly through what I'll maybe call best practices about onboarding, and then bring up Venkatesh to start his sort of back and forth Q&A with each other. So I'm going to talk about the supported environments, the software distributions that are available, the different forms that the software comes in. Hardware recommendations, we get that asked a lot. The end-to-end steps of uncrating a brand new machine, what that looked like, and how we got driverless AI onto it. Data sources that driverless AI can read from. How to automate the training process, which is a popular one. Once you kind of get some hands-on experience with the UI, then people want to be able to go and automate that. And then to productionize pipelines from driverless AI, what are the options there? And then finally, the top questions. So the supported software distributions and in supported environments break down really into cloud versus not cloud. So on the cloud side, we support AWS AMIs, a marketplace, Azure marketplace offering, Google Cloud Platform, Nimbix and Paperspace are two smaller providers, IBM Cloud Private, and the NVIDIA DGX Registry. So the same driverless AI software is available from all of these different sources. In the cases of the cloud vendors, of course, you'd want to choose instances as well. And we recommend that just for experimentation, it's fine to choose an instance with maybe 1 GPU. But to do real work, to do serious work, we recommend more than 1 GPU. So, for example, a great starter instance for trying a bigger workload would be the P2 8X large from EC2, which has 8 K80s. When you're installing your own, there are also different choices. There's the server versus desktop choice. Desktops really are just for trying things. It's more of a toy. We do support you to be able to try it on a Windows laptop, for example, but only using Ubuntu on the Windows laptop, so WSL. And no GPU support, just small data. For serious use, definitely we recommend servers, and I'll show some hardware specs. And just to give you a sense of what the different cloud offerings look like, here's the AWS AMI cloud offering. It's choose your own machine image, where you just type in H2O AI driverless AI and pick the version that you want to run. For Azure, there's a marketplace offering. It looks like that. For the Google Cloud Platform, there's a marketplace offering. So each of these have the software already there and ready for you to go. They are all bring your own license. So you need to go to the H2O website and grab a license. You can apply for one online yourself, and it'll just automatically send one to you. So the different ways of getting it in the cloud. If you want to install driverless AI by downloading the software and using it on your own local machine or in a cloud environment that you set up, not in a marketplace offering, you can do that through an RPM, through a Debian package, or through a Docker instance. So the RPM, we support these different environments. We support IBM Power 8 and Power 9, and on x86, we support RHEL 7 as well as SUSE Enterprise Linux. On the IBM platform for the RPMs, RHEL 7 is the only choice, and you need CUDA 8 or CUDA 9.0, with CUDA 9.2 coming soon. And we support all of the most modern GPUs from NVIDIA. The P9s generally, so far I've only seen them come with Voltas, so that's why only Volta is listed there. But really, once you get NVIDIA SMI working on your host, which is the sort of diagnostic tool for getting the GPU drivers up and running, there's a really good chance at that point that driverless AI will run just fine. And same for the Debian package. If you download the Debian package for the right architecture, whether it's IBM Power or x86-64, just go ahead, download it, install it, and as long as your CUDA is there and NVIDIA's SMI is working, you're more than likely good to go. In terms of the Docker support, we support both IBM as well as x86. And basically, if you've got NVIDIA Docker working on your platform, then there's a really good chance that driverless AI is going to just work. And in fact, this was our original method of distributing the software. We started introducing RPM and Debian approaches because people kind of wanted it. But we actually started with the Docker approach first, just because it is so nice and consumable and easy to use. But these are the three choices that you have if you want to go and install the software yourself instead of going for the cloud option. So on the hardware side, we definitely recommend that you have more GPUs. So more GPUs is better. And on the IBM side, a P8 with 4 Pascals, which is the Minsky box, is a great box. We've definitely got customers using that. We ourselves just got our hands on a Power 9 box with 4 Voltas, the Newell box. And for a setup like that, we absolutely recommend lots and lots of cores and lots of memory, because when the GPUs aren't working, the bottleneck is the CPUs. So the more you have, the better. Definitely don't skimp on CPUs. On the x86 side, I would recommend dual core, dual socket, I should say, at least. And again, 4 GPUs is better than 2, and that's better than 1. So the more you can get, the better. The existing DGX goes up to 8 GPUs, and the next gen goes up to 16. So there's definitely a scaling up kind of a factor happening in terms of the build out possible with GPUs on a single system. I would also say for all of these configurations, fast storage is really, really good. So especially for Docker-based environments, fast storage makes a tremendous difference. It's unbelievable. I was really pretty surprised when running on machines with and without SSD, NVMe type drives. So don't skimp on the storage. The extra, tiny amount of money compared to the overall server build-out cost is insignificant, but the impact is really a lot for Docker-based workloads because they're so disk intensive. And so to do what we just did, which is to uncrate and get a new IBM Power 9 system from uncrating to creating models, to creating feature engineering pipelines with driverless AI. These are the high-level steps we had to do. Basically, enable your Red Hat Linux, install your GPU drivers, install CUDA 9, grow the disk volume. It turns out that the default state that machine was sent had a tiny disk, which we realized by filling it up, by training too many models. And then, fortunately, there's a nice sort of Linux volume management setup there where it's easy to grow it without reinstalling the OS from scratch. So we just had to grow that, so just be aware of that. And then we had to open the firewall port, download the software, install the software, and bam, you can run it at that point. So we got it up and running within a day, pretty smooth, I would say. For us, the hardest part was actually getting Red Hat enabled because we had to get a new Red Hat subscription. And this is the same stuff, but just in a little bit more depth. I won't go over this. I'm just sort of including it as documentation for the actual steps we had to do to get driverless AI to run on this brand new system. In terms of data sources that are supported, we support lots of different file formats, comma-separated value, tab-separated value, text files, gzipped files, bzipped files, feather files, ARF files, Parquet. We've got a number of different connectors that are in the product, and the number of connectors is continuously growing. So we've got 3 more that as I've been asking folks on the team today, what are you guys working on in terms of connectors? I heard 3 more today that I didn't even know were in development. And so Minio, Snowflake, and KDB are going to be available soon. And today in the product, you can get, of course, local file system, HDFS support, S3 support, and Google Cloud Storage and BigQuery. And we're constantly adding more file formats and connectors. So if there's something that you really want that isn't here on the list, then just let us know what that is. In terms of automating driverless AI, training, the whole training process is, even when you're using the UI, the web UI, it's done through an RPC approach. And so there's also a client, for a Python client, that is able to be driven through code. And so here's an example of a piece of code that you can use to automate the ingestion of the data, automate the training process, and then to be able to download the model artifact when you're done. So not very big, one slide. I didn't actually even delete things here. This is what it is. As for productionizing driverless AI pipelines, this is another area that I would say H2O has spent a lot of energy and investment in over the whole course of the company and all of our products. So being able to take that model artifact when you're done with producing a pipeline, and I keep using the word pipeline because driverless AI has this focus on feature engineering. It's not just building a model, but it's building a feature engineering pipeline in order to create better features for the model to find signal from in your data. And the productionizing of that includes that feature engineering pipeline. So when we talk about bringing an artifact to production from driverless AI, we talk about it as a pipeline, and you'll see that in the documentation. And so we got 2 approaches to this. One is the Mojo approach, and for those of you that are familiar with the core H2O3 product, the Mojo it's in driverless AI, the same concept. It's basically an artifact that you can then run with a Java library, and it's very, very lightweight. It's got, as a design goal, very low latency. It's meant for real-time use. You're able to give it 1 row at a time, make 1 prediction at a time in production. It's very embeddable, and you could wrap a service around it if you want to, or you can embed it inside of your application if you want to. And as I mentioned, the feature engineering part is included in that pipeline. There's also a Mojo for model interpretability. And so for those of you that have heard about the model interpretability part of H2O, that's actually a whole second model that's used in order to make predictions about reason codes, for example, for individual data points for your model. And that's also an artifact that's extractable. The second kind of artifact is the driverless AI Python pipeline artifact. That's a more heavy footprint. It's all Python and using the libraries that driverless AI uses underneath. So things like, NumPy, et cetera. And so because it's pulling in all of those C-based artifacts, it's definitely a heavier footprint. It's good for batch applications. We actually use it as a reference implementation for testing that the Mojos are giving the right answers. And that because of the Python implementation being really the standard implementation from different packages that we pull to put into the feature engineering product part of driverless AI. Usually the Python pipeline will have new features first, and the Mojo will work then to implement those same features into the Mojo for the real-time scoring applications. And here's an example of the driverless AI Mojo code. Again, I didn't actually cut it. This is the real size. It's basically intended to be really small. It's reading in an artifact, reading in a model artifact, pulling in a few libraries, importing a few libraries, creating a row on the fly, and then making prediction. So very, very concise, extremely embeddable. And so let's go to the question and answer section. So Venkatesh and I put together a list of questions, and I'll hand it over to Venkatesh to talk about them.
Thanks, Tom. As Tom mentioned, we have been working with our customers for driverless AI deployment for close to 9 months, and I was just reflecting back to see what type of questions are the most common questions around deployment of driverless AI that kind of people usually ask me from an understanding and clarification perspective, right? So I kind of divided this into 2 parts. One is how a lot of questions around the training side of driverless AI, which is the driverless AI deployment itself. And then, of course, the model deployment part, the Pojo, Mojo, not the Pojo, but the Mojo and the Python scoring pipeline, right? So some of the questions, the most common ones, since we talk a lot about GPU, there is always this assumption made by customers that we only run on GPUs, but that's not true. Driverless AI can very well run on CPUs as well. So if you have a really good CPU machines, we can run on a vertical, very powerful CPU machine. Just going to be a little slower, but you still can, run on a long weekend or just start a job on Friday and you can go home and it will get finished by the time you come back on Monday, right? So technically that is possible. So it would work on a CPU machine. And from a scoring pipeline perspective, our scoring pipeline works on CPU only, so that should be fine. The other question is around Docker native install. Again, Tom covered some of those. As we started, our first deployment package of driverless AI was a Docker install only. And we have just started supporting other native installer type capabilities like RPMs and debs. So if you are a Docker shop, you like using Docker, then you have a lot of flexibility of installing driverless AI as Docker. It has its own pros and cons, but if your security allows you to do that, Docker would be a great way to deploy. But if you want to go native, we do have now support for native for all the platforms that Tom just mentioned, right? And we have now available in the download page as well, right? Yes. Yeah, so we have made all the installer packages, Docker, RPMs, and debs available on our download pages. The other question is around security, authentication, authorization. The moment your first experiment on your laptop is done, then you start thinking about putting it on the server, and then you start thinking about protecting your data and how you want to kind of divide and authorize, right? So we have built Active Directory LDAP integration into driverless AI. Early version of this capability already is in the product. We have some customers who have already deployed and are using it. So yes, technically you can integrate driverless AI with your in-house LDAP or Active Directory type system for authentication and authorization. In many cases, what I've experienced is every large enterprise have their own little nuances of Active Directory deployment or LDAP deployment. So usually we have to work with them a little bit more closely to kind of make sure that it works in their environment. But from an abstraction or the capability perspective, this already is in place. SSL support, this is another enterprise-oriented question. People are always curious. The fact that our UI is a browser-based UI, do we support SSL-based deployment? So technically, yes, you can install SSL in your environment. Can I run multiple instances of driverless AI on one GPU server? Yes, if you're doing Docker. So technically, you can configure Docker to pick resources from driverless AI, 1 GPU, 2 GPU. If you have a large GPU machine, you can divide the GPUs for different groups or different departments. You technically can have multiple instances running. With RPMs, do we allow that, Tom?
So for RPMs and DEBs right now, it's intended to be more of a server-based thing, so you install one per machine. Although we're talking about ways of, and this is not available yet, but we're talking about ways of supporting kind of a per user-based user mode install. And then you would be able to run more of them side by side if you gave them different ports.
Awesome. Windows 7 laptop, this is another very common question that gets asked. So no, we do not support Windows 7 laptop. And the reason behind is Docker doesn't run on Windows 7 sometimes. So we kind of, if you have a Windows 10 machine with Docker running, so you can run Driverless AI on a Windows 10 with Docker.
With the
WSL, okay.
With Ubuntu from the Microsoft Store.
Okay. So there you go. So there is another option, but most of the time, this question comes to me from really large financial companies or insurance companies who have a very locked down Windows laptop environment, right? So Windows 10 support is there with Docker. Again, you cannot do a lot. You can just play with the product, experience the product, but again, if you want to do some real work, you may have to put it on a larger server. Right? Driverless AI on a air-gapped environment, which is a machine without network connectivity or internet connectivity. This usually we have noticed with power machines. A lot of large enterprises who have IBM power machines, or even in a much secure zone that they have with no internet connectivity, Driverless AI can run without any problem. So we have kind of packaged our software in a way that it is self-contained and you can install in that environment. Anything?
Yeah, and I would also add the installation process is really just one RPM or DEB or Docker file. It's fully self-contained, so installing in internet disconnected environments is relatively straightforward.
Any other questions on installation that I've kind of missed, but you have top of your mind? Yes. So the Active Directory integration from a user management perspective, that's what we support so far. So the idea really is you can configure Driverless AI to connect to your Active Directory environment for authentication. And all the user management you would do really on your Active Directory side. We have not done any specific user management type capability.
Well, I guess what I would say is that once you've gone to the driverless AI web interface and logged in, you'll see your stuff and not other people's stuff. So the software does separate experiments and data sets based on per user.
We create something we call user-based workspaces. So every user will have their own kind of workspace. So at least that security type, separation type environment is there. Yeah, so quick on deployments. So this is, again, one of the core strengths of H2O, which is once the experiment is done, we give you a model deployment package, which is independent of Driverless AI. Mojo specifically here, we now call Mojo 2 runtime, which is the next version of Mojo, which contains a model as well as the pipeline for transformation. Again, can the model be deployed as a Docker container? Yes, we can do that. We are working on a more easier approach to do that. Maybe we'll be able to generate a container for you. But today, we have customers who have attempted to do that as well. So technically, that is possible. As a microservice in Kubernetes, we have requests from our customers. We are working on it, but again, technically, this is doable, where you can take a model pipeline, create a Kubernetes type environment, and deploy it as a microservice. Right? One-click deployment model? No, not yet. We do not have a one-click deployment model. Again, this is another question customers have asked us a lot. Something we are looking into to see if this is something we can support, but at this point, there is no one-click deployment button, but we allow you to download and deploy it in your enterprise environment the way you would like to scale it. Right. The different driverless AI Mojo pattern, as Tom mentioned earlier, the fact that this is a Java artifact, we have many different ways this model could be deployed in production. You can embed it in part of your Java pipeline. You can create REST APIs, so if you want to expose REST APIs, you could do that. We also have Hive UDF type integrations if you want user-defined functions for Hive queries or Hadoop environment, Spark UDF, you could do that. We are working on something we call a deployment template code base. So the idea would be that we'll be able to provide you a template code for REST API or Hive UDF, and then you can kind of take your Mojo and use that templatized code for your deployment purpose. In our documentation, we do have a lot of different design patterns that we have observed with Mojo, our customers have done. Most of those will be kind of moving to Mojo 2 as well, right? But for our customers, Tom offers his time to help out from architecture discussion on what would be the best way to get the model deployed in your environment based on your needs and requirements. So we could do that as well. Any other questions on deployment? Yes? The connectors are for training, right? So in driverless AI, we are making it more easier and easier for you to consume data for training. For deployment, you'll have to figure out what would be your deployment scenario to pass data.
There's another way of deployment which we didn't actually discuss, which is using the driverless AI server itself. And so if you use the server itself as a batch scoring thing, then the connectors could be used to score in that situation. But it's really intended more for training, like Venkatesh said. Other questions?
All right.
No? Okay, thank you very much.